LifEye, a computer intelligence-driven eye tracking service. Hello, my name is James Cassidy, and I am the Vice President of Engineering and Lead Developer for the LifEye Eye Tracker. This is an overview of the design paradigm and system infrastructure for our eye tracking service. My aim is to describe our technology in simple terms, understandable to both end user and prospective developer alike. To begin, I would like to define what is encompassed by the LifEye service. LifEye provides a server built for data computation and interpretation. This server can be interacted with through client interfaces, which can be built on both mobile and desktop platforms. Visual information, such as an image or a video, can be sent to the server. From this information, the server will calculate points of vision. Through configuration on the client interface, the return data can be utilized for a variety of applications. The LifEye server stack consists of four main parts: the receiver interface, the computer vision network, the eye tracking algorithm, and the storage repository. The receiver interface sets up a communication service and handles the type of data sent to the server. The computer vision network will take the received data and isolate regions of interest necessary for the eye tracking algorithm. The algorithm will interpret points within the regions of interest and perform calculations to produce points of vision. The storage repository takes information from each of the previous parts for use by client interfaces. It also keeps a client's account information to provide a basis for a developer-only administration site. The receiver interface provides a full communication service for client interfaces to connect. The client can send device-specific metadata and visual information to the server. The metadata will allow the server to modify its calculations in later parts in order to provide accurate points of vision. After this, the receiver can operate in two different ways based on the type of visual information that is supplied. If an image is sent to the server, the file will go through quick pre-processing before being supplied to the computer vision network. This operation focuses on efficiency, which can be used for real-time applications. If a video file is sent to the server, the video will be separated into frames, which can be processed individually. This will allow for a more data-rich interpretation through multiple vision points in a single test. Once the file is processed, it will be passed through to the computer vision network. The computer vision network is an artificial neural network trained to extract critical regions of interest within the visual information. Specifically, the network will separate the eye regions from within images, which will be sent to the eye tracking algorithm for calculation. In order to provide accurate detection regardless of the scale of the image, each file is scanned through in a robust manner. The efficient design of the network allows us to fully scan an image in a matter of microseconds. Our training data for the network includes people of both sexes and many races and ethnicities. This gives us a high rate of detection with a low rate of false positives. Once the regions of interest have been extracted from the image, these regions are then processed by our eye tracking algorithm. The eye tracking algorithm will provide accurate points of vision based on the extracted regions of interest from the visual information. The algorithm takes certain environment variables from the metadata collected by the receiver interface. Once it has been modified, the algorithm locates points, such as pupil center and Purkinje reflections, to extrapolate line of sight. It then correlates this with previously collected training data to calculate a point of vision. The point of vision is recorded in the storage repository along with the metadata and visual information for later use by the developer of the client. The storage repository is an encrypted database that ties into each of the previous parts of the server stack. It collates all important information into a single location. This information can be packaged and collected for human interpretation, or it can be returned back to the client interface for use in an application. Information sent by the client will only be accessible by this client through the use of a unique API key, as well as login information for use in our administration portal. This allows us to protect your information and comply with research and security standards. As we move forward in our continued development of the LifEye eye tracker, We hope to provide more accurate visual points, real-time interpretation of video files, and an easy-to-use library to simplify integration of a client interface into your existing app. Our modular server stack allows us to easily replace parts of our pipeline and better tune it to more platforms. Through cooperation with research labs and mobile app developers, we aim to increase sophistication of our service and adapt it to your specific needs.